The pretreatment components should be installed according to the manufacturer's recommendations. The pump tank, pump, controller, and filtration components are installed to allow easy access during system maintenance. Drip tubing can be installed using a trencher, static plow, or vibratory plow. The trencher opens a shallow trench. The tubing is then placed in the trench and covered with soil. The static plow cuts through the soil, with the tubing fed behind the plow. The vibratory plow cuts through the soil with rapid oscillation. Here, tubing is also fed behind the plow. With all three, soil must be compressed around the tubing to minimize water movement up to the soil surface. Individual runs of tubing are connected by looping the ends to form a drip lateral. These laterals are connected to the supply manifold and to the return manifold to create a continuous loop. Installation should ensure the proper elevation of components and surface water drainage while maintaining natural soil structure. Operation and maintenance of a subsurface drip system can be divided into care for each individual component. The pretreatment devices must be maintained to ensure delivery of the expected quality of water to the drip system. The septic tank must be inspected and pumped on an as-needed basis, typically every 2 to 3 years. All parts of this and other pretreatment devices should be inspected and maintained according to manufacturer's recommendations and guidelines. The pump tank for the subsurface drip system should be inspected every 4 months. This includes verifying system pressure and capacity. The water level sensors should be activated to make sure the controller is operating. The alarm water level sensor is activated to make sure the audio and visual alarms function. The controller is inspected to evaluate the function of the timer. If the timer is not operating, the system will not run. The controller may also record the pump run time and the number of dosing events. This information can be used to monitor the amount of wastewater dosed into the drip fields. The filtration system should be checked for normal operation. Plugging of the filters would cause the system to back up. Some filter systems automatically backwash, while other systems bleed a portion of the flow off the bottom of the filter to carry large particles out of the housing. The filters are removed, inspected, cleaned, and replaced. Some service providers keep spare filters and automatically replace the dirty filter during each maintenance visit. The laterals should be flushed by passing effluent through the system and returning the flush water and dislodged materials to the pretreatment device. Plugging the emitters would cause uneven distribution, resulting in uneven irrigation of the grass. Flushing the lines removes biological growth from the tubing and fine soil particles that may have been drawn back into the lines. This flushing operation may be performed automatically by the controller or manually by the service provider. The drip fields should be inspected to determine if leaks exist by checking for wet or soggy areas in the field. Any damaged section of tubing will need to be repaired. The air relief valves should be inspected to ensure proper sealing during operation. If solid particles are caught in the air relief valve, it may stick. Valves may need to be insulated to prevent ice from holding the valves either open or closed. Open air valves would allow water to exit the system during operation and potentially overload an area with water. Air valves stuck closed do not allow air back into the drip laterals when the pump is turned off. This may result in soil particles being sucked back into the emitters. Inoperable air valves need to be cleaned or replaced. Reports generated during system inspections should be retained by the inspector, provided to the homeowner, and a copy filed with the regulatory agency. Wastewater is an unavoidable part of our lives, but on-site treatment systems are an effective way to deal with this wastewater and its contaminants. They protect public health and the environment, all the while raising property values and ensuring the viability of our communities. Subsurface drip dispersal is one possible component in these systems. When properly matched with the right counterparts, subsurface drip dispersal transforms wastewater into a benefit for everyone.